Hey guys, welcome to 2.4 derivative of a composite function, the chain rule. In this lesson, we're going to be learning how to take the derivative of complex functions using the chain rule. Now what I mean by complex, let me start with a simple function. For example, y is equal to x squared plus 1. You know what the derivative of this is? The derivative is 2x. But what if I make this function more complex? For example, squared. Well, you would have to do the FOIL. And when you do the FOIL, you should get x to the fourth 2x squared plus 1. And then a derivative of this would be 4x cubed plus 4x. Simple, right? Okay, but what if I make it a little bit more complex? For example, not to the second, to the fourth. Well, that's not easy to do because then you have to do the FOIL 4 times. So in order for us to do this much more quicker, we're going to use another rule called the chain rule. And this is really the last rule that you'll learn about derivatives. And after that, we'll be talking about more applications of derivatives. But before we start the chain rule, let's talk about composite functions. In Algebra 2, you guys learned that composite functions are functions within a function, and they're usually denoted as f of g of x, where g is the inside function and f is the outside function. Take a look at the first example. If f is x to the 7th and g is 3x squared plus 5, then f of g of x is 3x to the 2nd plus 5 to the 7th. How does that work? Well, composite function says that if this is my inside function, for every x in f, I'm going to plug in g. Very similar to the next example. The next example states f is sine x, g is x cubed, so f of g of x is sine, and then the inside of sine belongs a x cubed because sine had originally an x and it got replaced with x cubed. And then the last one's the most important one. If I have f of x is equal to x cubed and g is my cosine x, then f of g of x is cosine my inside function, right? That's my g. And then the outside function is the third power. So it looks like x to the third, but now x became cosine, which we know that these two can be rewritten the same as this. Let me go ahead and just make that very clear. Cosine x to the third is the same thing as cosine cube of x. Those two are exactly the same meaning. So let's skip down all the way to the chain rule, this part right here. I'm going to give you guys the general rule for chain rule. Chain rule says that whenever you have a function within another function and you want to take the derivative of the functions, then the chain rule goes as follows. The chain rule says it's f prime of g of x times g prime of x. That is a chain rule. For example, let me do this problem right here. Imagine taking the derivative of this, having to FOIL 7 times, and then taking the derivative of each term. Well, let's use the chain rule. What appears to be the inside function? The inside function is my g. So I'm going to say 3x squared plus 5. What is my outside function? What is the big picture? Well, the big picture is that it's being raised to the 7th power. So it would look like this. X to the 7th. That is pretty much what's going on. Something is being raised to the 7th power, and that is 3x squared plus 5. Okay, so f of g of x is 3x squared plus 5 to the 7th. Now let's take the derivative of f of g of x. Okay, notice that the derivative contains the chain rule contains three components. you need to know what G prime is, you need to know what G is, and you need to know what F prime is. Okay, so let's state them. G is 3x squared plus 5. What is G prime? G prime, well, that is 6x. And what is F prime? F prime is 7x to the 6. Now let's plug it in all together. So notice, my chain rule has a composite function. It's no longer f of g of x. Now it's f prime of g of x, which means that I have to plug in g into my f prime right there. So it's going to be like this: 7 parentheses 3x squared plus 5 to the 6, and then that only takes care of this part. That's only this part here. What's left is the chain, this derivative that's being attached to my function. So what is g prime? G prime was 6x. Cleaning this up, you get 7 times 6x, which is 42x, 3x squared plus 5 to the 6. And that is my chain, that is my derivative of this composite function. Y is equal to 3x squared plus 5 to the 7th power. Now, what I mean by composite function, I mean that every function is a composite function, every single function. You just don't know about it. For example, you can give me the most simplest function, x squared. Well, x squared is a composite function. How so? I can say that f of x is equal to x squared, g of x is equal to x, and f of g of x is, here's the big picture. Something is being squared. Well, what is the inside function? Well, I'm going to say the inside function is x squared. You've been dealing with composite functions pretty much since you guys started learning about functions, period. Except you guys weren't taught it that way. But now, since you guys took Algebra 2, this makes much more sense. Composite functions are actually everywhere. And there's an example of a composite function there. Even the most simplest functions are composite functions. As we've seen, complex functions are obviously more notable to be composite. So let me go ahead and end this video. That was an introduction of the chain rule. In the next video, I'll be talking about the examples of chain rule. So see you guys in the next video.